Hello, Mr. Ruth here. I am making a short video to just talk to you a little bit about what is going to be on the test on Friday. So this is kind of the standard review packet. If you haven't printed out the review packet, you might want to do that, or at least take a look at it so you've got both on your screen. All right, so the test on Friday, I'm giving you 90 minutes. Okay, I'm going to post it at 11:30. And as long as I get it back from you by, like, let's say 5:30 p.m., then it's timely. So you choose the 90-minute block you want to do the test in whenever you want. It is no notes, no book, no internet, none of that. We'll just, so you're expected to do it kind of with just the test. There are some formulas, though, and the formulas that are on the test are these formulas. It's exactly this page that is on the test. So you've got all these formulas, which is the magnitude and direction from when we were doing wind and current problems. They're in polar to rectangular. And then also going back from polar to rectangular here. So this is rectangular to polar. This is polar to rectangular. We also have the vector formulas from the IB formula booklet. Vector equation of a line is a big one. Angle between two vectors you'll need to know. And in order to do the angle between two vectors, you'll need to know the dot product. You'll also need to be able to calculate magnitude. So a lot of these formulas are going to be used on the test. All right, how many questions are the test? It is 3 no-calc and 5 calculator questions. It's 50 marks. So with 90 minutes, you should have more than enough time. The intent here is to say, all right, this is, we don't want to time challenge you. I know sometimes people, the houses get loud. So if you lose 10 minutes because a sibling or a niece or somebody's making a lot of noise, you should still have plenty of time. All right, what's on this thing? Well, I listed 9 different categories of questions. I'm not saying everything is on there, or there's every single one of these is on there, but these are the things that I drew from for the unit. So understanding the idea that a vector can be represented as a line, right? We've got this form R equals A plus TB. T is almost always going to be time in this format. And A and B are vectors. A is the position vector. That's like the starting point. That's the B in the y equals mx plus b. B here is the direction vector. This more corresponds to the slope. All right. If you have 2 lines, like so, and this starts at 1, 2 plus t, negative 1, 2, and this is at 1, 3 plus t, negative 1, 2. As long as the 2 direction vectors are the same, then those vectors are going to be parallel. Okay, using vector line format. If I give you 2 points, you should be able to find the line. So this is a question right here. It's the very first question in the review packet. And so it's something you need to be able to do. In order to find the direction vector, you use end minus start, like we were doing last unit. And once you have the direction vector, you just use one of the points as the position vector. So if you have 2 points, 1, 2, and 3, 4, then you do your end minus start, and you get and you end up with a line that's something like this, right? You end up with the position vector. I could have used either one plus t times the vector 2, 2. Given a vector line equation, determine if a point is or is not on the line. There's also questions like that on the review packet. Find the angle between lines. This is where the chapter 12 stuff comes back. If I'm trying to find the angle between 2 lines and I've got the equations of 2 lines, the key point here is we use the direction vectors. We do not care one whit about the position vectors. So the direction vectors are sitting right here and right here next to the t's. So I take those and I plug them into my angle between two vectors formula. Remember, this top one is dot product, not multiplication. It's dot product, not multiplication. The bottom, these are not absolute value. These are magnitude. So remember, make sure you know how to do this. Vectors in kinematics. Sometimes we use this format. Again, it's the same line format, but this is our starting position time the vector the direction vector is the velocity. So all sorts of ways we can twist this or kind of mix up the problem. If I give you the equation, maybe I want you to find a position. If I give you a line and a position, maybe I want you to find time. In every single one of these, though, I'm giving you at least 3 of these things, and I'm asking you to find the 4th. This one's a little different. Speed. You have to remember that speed is the magnitude of velocity. So velocity is a vector. Speed is just a number. So if I ever say, here's what's the velocity, I'm expecting an answer like this. If I ask what's the speed, I'm saying, tell me the magnitude of this. In other words, Pythagorean theorem this thing. So, what you're doing is this plus this, and the speed is just 5, a single number, or, 5 miles an hour, depending on the units. F, given 2 vector lines, show whether or not the objects will collide. There's one in the packet on that, so I suggest you look down at the example answers. Understand how vectors can be represented in a variety of formats, right? We have rectangular form. This is using brackets like so, 3, 1, 2. Or we can use I, J, and K. You should be able to use both. Remember that this vector would be the same as this vector, just written different ways. And then finally in polar form. In polar form, our angle is this angle, the angle between the positive x-axis and the vector. That's our theta. It can go all the way around to 360, just like in trigonometry. And then we also have a magnitude, which is the length of this vector. So very different from rectangular form, which is much more like the coordinate system. We should be able to convert between the 2 forms. That is that are these formulas right here. Understanding bearing notation. So the difference between polar notation and bearing notation is bearing notation always kind of starts either north or south, and the angle is the angle of deflection from north or south. So for example, it's this angle. It's not the angle with the positive x-axis. Bearing notation is always going to look something like this. A direction north or south, an angle in a direction east or west. You should be able to do headwind, tailwind problems. These are problems where you've got a current or you've got a plane flying in the wind, and it's going either directly in your face or directly behind you. So these tend to be much simpler. If you're going at 50 miles an hour in the air and there's a wind of 10 miles an hour, would be a tailwind. Then overall you're going 60 miles an hour. Finally, crosswind, cross-current problems. That was the bulk of the homework for Monday. Remember, what we're basically doing with all these problems is you convert to component form if it's not already there. Get it in component form. And then you add the vector that represents the object traveling to the vector that represents the wind or the current. And what results is what we'll normally call like the true velocity of the object. So this is the velocity of the object. This is the velocity of the wind or the current, and that gives us the true velocity. All right. There's other questions, a lot involving crosswind, cross-current problems. I refer you to the homework or for the materials that we've used. All right, best of luck. I will have office hours on Thursday. I can have extra office hours on Friday morning. So one last push, and then we're done with our IB curriculum. Have a great one, guys.